All right, everybody. Part 3. I am Mr. Canfield. Algebra 1, Chapter 2. That was totally in order. All right, so this last one, we're on number 12. Find the x and y intercept of the graph of the equation. 3x plus 7y equals 21. So remember, when we're finding the x and y intercepts, our little trick was, well, the real thing that we're doing is an x-intercept and a y-intercept come from the other letter being 0. So if I want the x-intercept, that means the y-intercept is 0, right? But remember, if the y is 0, then it's gone. And then it just says 3x equals 21. So you just divide both sides by 3. And that's how you get your x-intercept. So 21 divided by 3 is 7. Bam. So we just back up. Same idea. Cover up the x to find the y-intercept. Divide by 7. We get 3 this time. So we've done a bunch of those. And then we can use that to graph, remember? So we can take our 5x minus 8y equals 40. So if I'm fine, oh, you're fine. So for the first one, excuse me, plugged in 0 for y, divide by 5, 40 divided by 5. My x-intercept is 8. And then I do the same thing for my y-intercept, right? But this time when I plug in the 0 for the 5x, it's going to be negative 8y that's left. So now I need to divide by negative 8. So 40 divided by negative 8 gets me negative 5. So plot my x-intercept of 8, my y-intercept of negative 5. Boom. Let's see if we're right. I made a mistake. What is my mistake? Wait. What did I do wrong? Let me look at my graph again. Oh. Wait. Let's see. My x-intercept was 8. 2, oh, these are going by 2s. So that's actually 6 right there. I need to go to, and I should have looked up here. I went to 6, but I need to go to 5. There we go. Okay. I guess that's what happens when we assume. I assumed the scale would make sense. I didn't actually pay too much attention to the scale. Let's see, what's the equation of this line? Oh, this is a horizontal line, right? So remember, it's either going to be an x equals line or a y equals line. I want to remind you that they kind of do the opposite of what you'd expect. X equals lines go straight up and down. Y equals lines are horizontal. So this shows me, since it's horizontal, that it's y equals 1, 2, 3, 4, 5. Awesome. A, B, and C? What are you talking about? This isn't A, B, and C, and this is where, well, let's think about this. If this was a standard form line, AX plus BY equals C, and I wanted to just say y is equal to 5, well, the first thing you'll notice is there's no x there. So the only way for that to happen is if there was a 0 with the x. So I'd say that A is 0. And if you're like, Mr. Canfield, we never did this. I know we didn't. I wanted to put a couple extension problems on our review to have us think a little bit more deeply about these things. It's okay. But hopefully that makes sense, even though we haven't really done that before. Hopefully you can see that the 5 on the other side, that's where C is. So that'll be 5. Now, what number would go with the y to make that make sense? 1. There we go. Let's see what's next. All right, here's our next one. This is another one that we have. I don't think I've given you any like this before, but it's basically ones that we've done. 3x is equal to negative 105. Well, we didn't talk about anything where there was a letter and a number. We've only done like x equals and y equals. So I can turn this into an x equals really, really easily by dividing by 3. Negative 1 divided by 3 is 35? Negative 35. Now, if you watched my last video, you know that I make silly mistakes, so I'm actually going to double check that. Negative 105 divided by 3, I got negative 35. Okay. And it's an x equals line, which means, remember, that's straight up and down. So all I got to do is go to negative 35, which I'll count my scale carefully this time. Go to negative 35 and just make a vertical line there. That's annoying. Okay. So I need to use the x-intercept as one of my points. I didn't read the question. Use the graphing tool to graph a line. Use the intercepts when drawing a line. If only one intercept exists, use it and another point to draw the line. That's stupid. All right. I mean, sorry, that is objectionable to me, but that's fine. All right. Ooh, this one. I saw this question. I was like, yes, we have to look at this one. This is another one that's a little bit of an extension. 4, 0, and 0, negative 3. All right. So it's asking for a standard form line, right? So this one actually, this is going to be one of our ax plus by equals c equations. So when x is 4, y is 0. Wait a minute, that's an intercept. So I wonder, can we say 4x when x is 0, y is negative 3? Minus 3y? Then we just have to figure out what's going to go here. Well, these both go into 12, right? So would 12 make sense over here? Let's see what happens. Make y 0. Oh no, when I make y 0, that makes, this is 4 goes into 12 3 times. It actually switches them around. So maybe I need to say negative 3x plus 4y is equal to 12. Let's see if that works. So when x is 4, oh no, that gets me negative 12 there. So maybe it's 3x plus 4y. So when y is 0, the 3x goes in, that's 4, yep, that's good. Now 0, negative 3. Oh, nope, that won't work because we need a negative there. So I'm not expecting that's going to work for everybody. And they probably do it a little bit of a different way than me. But that'll get us there. Let's see how they do it. So they actually find the slope. Yeah, no thanks. I like the way that I figured this out instead. So you can definitely do their method, it'll work. But I like using shortcuts when I can. Okay. Let me zoom in nice and big so this is nice and legible. All right. A store sells gift cards in preset amounts. You can purchase gift cards for $10 or $15. You have $340. Oh, you've spent $340 on gift cards. Write an equation in standard form to represent this situation. And then we want to find 3 combinations. So we could say we spent $10 on one kind, and we don't know how many of those we bought. So we could say 10x, And then, I mean, you could also say 10y. That's fine too. Oh, no, 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 no. Let x be the number of gift cards that are $10. So that means that $10 times the number of gift cards we bought. That's our 10x there. And then y is the $15 ones. So that's 15 times the number we bought. So like if we got 3 of each, we would do 10 times 3 plus 15 times 3, right? But it says we spent $340 total. So we'd say 10x plus 15y equals the total amount. So now we want to find combinations that work. So all I need to do for this, right, we've got $340, right? 0 of the 10, 22 of the $15 ones. Let's see, can I purchase 22 of the 15? So 22 times 15, that's 330. So that's, it says that we spent 340 though, so it's not right. So I already know it's not A. What about 22 of the 10 and 0 of the 15? Well, 22 of the 10 would be 22 times 10, which is 220. So no, that's none of the 15s. So that's not, I know it can't be B either. Let's see, what about 1 of the 10 and 22 of the 15? Which remember earlier, 22 of the 15 gave me 330, and 1 of the 10 would be maybe $10 more, so that'd be enough. So I still need to check these other two, but I already know it can't be A and B. Let me look at D and see if the first option in D is possible. So if I do 22 of the 10, oh, that's our 220, right? And then 1 of the 15, that's not enough. Right, so it can't be D either. That means it has to be C. Just in case, though, I could have made a mistake on A and B. Let me try the other options in C. Let's see, 4 of the 10, that's $40, right? And 20 of the 15, that's $300. So that does work. And then 16 of the 10, that's 160, right? 12 of the 15, 12 times 15, oops, 12 times 15, 180 plus 160. Sure enough, it works. Okay, so it's got to be C. All right, and the last thing we're looking at is parallel and perpendicular. Does our zoom back to the, there we go, okay. Slope-intercept form. Slope-intercept form was our y equals mx plus b. X and y are both -7. Wait, but what's m? It says it passes through this point and it's parallel to this graph. What does parallel mean? Same slope. What's the slope here? My slope is -3. So m is -3. So -3 times -7 is +21. Excuse me. And now I can just subtract the 21 from both sides. Ooh. Got a little frog in my throat out of nowhere. So -7 minus 21 is -28. So remember, we just line it all up and drop it in. Oh, she dropped that peg when we were playing earlier. She'll get there. So let's see what would happen with, if it was the exact same thing but it had said perpendicular. The only thing different would have been, instead of this -3 here, Remember, perpendicular is opposite reciprocal slope. So the negative 3 would turn positive, and we would take the reciprocal. So it's currently 3 over 1, so it would be positive 1 over 3 if we were dealing with perpendicular. So that's the only difference. All right, and our final multi-part question. Too far. You've gone too far. Elijah and Aubrey have summer jobs. Elijah deposits the same amount of money into his account every week. The equation is y is equal to 125x plus 72. And it represents his bank balance any given week of the summer. Aubrey also deposits the same amount into her account every week. So which of these numbers do you think is how much he deposits every week? If he's doing it every week, it's over and over and over again. That's our slope. So he deposits 125 every week. Aubrey's also depositing, it says the same amount, so she's also depositing 125 every week. At the end of the third week, she has 398. At the end of the sixth week, she has 773. Let's see if that makes sense. So she's got 398 at the end of the third week. At the end of the fourth week, oh, you know what? I think I read this question wrong. Oh, no, I didn't. Okay. So she deposits the 773. So she's doing 125 every week, right? Well, if we know at the third week she has 398, how much did she have at the second week? That's where we can take 398 minus 125. We get 273. So that's the second week. That's the first week. But what about before she even started working? She started with $23 at the 0th week. So we could say Aubrey has y is equal to 125x plus that starting amount of $23. So what would these graphs look like, 125x? Well, their slopes are the same, right? That means different y-intercepts, so the lines are parallel. Whoop. They each deposited $125 each week. They started with different amounts. Elijah began with $72 in his account. Aubrey began with $23 in her account. I hope this has been helpful. And good luck preparing for your test next period, or next time we meet. Bye.